Today we will discuss programmable logic controller. So in short, programmable logic controllers are called PLC. For programming programmable logic controllers or PLC, ladder programming is used. We will try to understand ladder programming through a web page on our browser. Let us type www.plcfiddle.com and press enter. So when we will get this type of screen. Here you can see that there is a ladder type of thing. This is one rail of the ladder and this is another rail of the ladder. On this ladder, there are rungs. This is first rung, this is second rung. We can add more rungs also. Add rung. So I have now made 3 rungs. I can add more rungs. So now you can see there are 4 rungs. I can delete the rungs also if I pick it from here and place it here. So one rung has been deleted. One more rung I can delete like this. Correct. Now on these rungs, there are already some things written like the start button, stop button, motor, these things. So we can sort of delete them also. So I'm deleting them like this. Pick and drag. So by usage of mouse, we can sort of delete them. Right. So now I have only one rung. I can delete one more rung. So only one rung is here. Okay. And on the left hand side, you can see there is a start button. I can delete it now. Stop button, I can delete it. Motor, I can delete it also. So what I have now with me, this is one rail of the ladder, this is another rail of the ladder, and this is one rung. I can add rungs. 2 rung, 3 rung, 4 rung, 5 rung, 6 rung. I can delete the rungs. So this rung I have deleted, this rung I have deleted, this rung, this rung, this rung. Only one rung is left. Right? Okay, now let us see what is a contact. So there are these different types of contacts. This is normally open and this is normally closed contact. What is contact? Contact is sort of input variable. Like you get a input from some sensor. So it represents that thing. Or when we press some switch, so that closes the circuits. So that is a representative of a contact. What I can do is I can take a contact from here, pick from here and place it here. So here I have one contact which is normally open. Now if you click on this variable, nothing is appearing. Now contact is basically a Boolean thing. Either it will be on or it will be off. So I can create a Boolean here on the left side. Let me name the Boolean as RAM. Okay, so I have created a Boolean RAM, and now if I click this contact, so that option RAM will come. RAM is there. So if on the left side, if I put it on, so you can see that RAM has turned on. If I put it off, so RAM is off. The green signal represents it is active, on. Right. So this is about the contact. Now then there are coils. What is a coil? Coil represents the output, like the actuator. Like actuators can be some motor, right? Some pump. Okay. So these are the actuators which get turned on when they receive some signal from the PLC. So I can take a coil from here and place it here. Right. Now, if I turn this RAM contact on, so this variable output variable should also get turned on. But since I have not taken any variable output variable here, so I need to create a boolean first of all here. So again, I will create a boolean. Let me name this boolean as motor underscore field. Let us say field motor underscore field, right? And here now I will have the option to select this motor, correct? Now when I turn the RAM on, this motor would also get turned on, correct? So you can assume that if I have written this type of program in a PLC, whenever RAM would get a high signal, on signal, the motor would automatically get turned on, right? Now let us try to simulate AND logic now here. If I take another this contact here, so this is another contact, and I create another boolean, let us say Sham, right? I take it as Sham here, this second contact. Now this represents AND logic. How it represents AND? Because when RAM as well as Sham both would be together on, then only motor underscore field would be on. So if I make RAM on, motor underscore field is not on. If I make Sham on, then only motor underscore field is on. So this is representative of AND logic. Similarly, we can also create OR logic here. How we can create OR logic is we'll press other here and use this option to create a parallel thing. Correct. Now I will place it here and I will place this drag Sham and place it here. Now either if RAM is on, motor would be on. Either Sham is on, then also motor would be on. So I am putting this RAM on. You see, motor underscore field is on. If I place Sham on, then also motor underscore field is on. Correct. Now let me take one contact. This is normally closed contact. I place it here. Now we'll name it as, let us say, create another boolean switch. So I'm creating another boolean switch. I'm pressing AND. I take it as switch here, correct? So, and this instead of Sham here I take as motor underscore field. So now if once RAM is on, so when RAM is on, motor underscore field would be on. But if I now make RAM off, but still now motor underscore field would be on. It will keep running. Why it's happening? Because in parallel I have used this option of using the status of motor underscore field in the programming, in the letter programming. So if once by pressing the RAM button, motor underscore field has been turned on, then if you again keep pressing the RAM button, the motor underscore field would not get turned off. For turning off the motor underscore field, we would have to now press the switch. Then motor underscore field would get turned off. Now if this switch is again pressed, then motor underscore field would not turn on. For turning on the motor, we have to again press this RAM on. So this RAM button is for only starting the motor. This programming allows this, and the switch button is only for stopping the motor, right? So okay, so if this RAM is on and the switch is again pressed, this switch is pressed, then motor turns off. If I press the switch again the motor turns on. So this is about contacts and coils. So now let us see other features in this PLC logic. So I'm putting it off. Let me delete this one also. Now another thing, the math. Now this is add, subtract, all these variables are there. We can, place it like this. So now these are numbers. Numbers can be added. So you'll have to create numbers. So this sham I can delete, switch I can delete. I'll create some numbers. Let us say first number, add, then another number second, add, right? And another number third, add. So if I make first number as 4, second number as 5, right? And enter these numbers. And here I take as first, here I take as second, and here I take as third. So what it will do, it will add first and second number in the third number. So you can see that 4 plus 5, 9. So if I take here as 2, so 5 plus 2 is 7. So 7 will come in the this variable third. Right. So similarly, there are options for math. For subtract is also similar option. Multiply, divide, move. Similarly, there are options for variable greater than, less than, equal to. So let us try to see how we can use these variables. So what I'm going to do is that I'm creating another rung. Add one rung I have created, and here I will use this variable, let us say greater than variable, and here I will use another variable boolean. I will create one boolean first, let us say pump. So I've created a pump here, and here I will create add one coil. This coil will drag and place it here, and here I will select pump. Correct. So I'm putting it off. So variable, let us take it first, and this one is, let us say, second. So the output of this would be high when this first is greater than second. Now first is 2 and second is 5, right? Now 2 is not greater than 5, so output is low and the pump is off. Now if I make this first as 20, if I make it as 20, then 20 is greater than second. So first becomes greater than second, so pump will be on. So this is how this option of compare can be used, right? Now next is the timers, on delay timers and off delay timers. So let me clear the things first of all. Let us delete some things so that we have option to experiment more. I will delete this thing. Right, so okay, now I will take this option of on delay timer. So I will place it here, right? And since I have placed on delay timer on the right hand side, on the left hand side I have to create it also. So I will say, let us create a timer by name punctual, right? So a timer has been created. When a timer gets created, if I press this this triangle, So I will get these 5 parameters: en, tt, q, acc, pre. Now what is en? En is the enable. Enable means the timer is enabled or not. tt means timer timing. When the timer is working, then timer timing is on. When the timer is enabled, it is on here. Q is the output of the timer. When the time of the timer is over, then Q turns on. Accumulator gives the current value of the timer, and this is the preset value which we can set in a timer. Let us say I set a value of 10 here, and I enter it like this here, right? So now I have to select the timer here punctual. So I have selected the timer punctual here, right? Now so you can see this accumulator is getting value incremented, and it is moving towards 10. So as soon as it becomes 10, en has become on, and q has also become on. En is already on. Sorry, en is on, and this q is has become on. So these are the status of the different parameters of the timer. That means en is on, tt is off, q is on, acc is value is 10.083, and preset is 10. Now we can now use these statuses of the timer. How we can use it? So what I can do is that I can take a contact here, right, and use the value of q here, the q value of the punctual timer. So now since q value of punctual timer is on, so the pump on the right hand side is on. If I, instead of q, if I take the value tt of the punctual timer, so the pump has now become off. And I can also take the status, enable status also of the timer, and the pump is becoming again on. So a timer allows us to use 5 of its parameters in the programming, right? So again, if we have to see how it works, let me take the preset value now as let us say 20. So 20 is the preset value of the timer, right? And here I'm taking the Q status of the punctual timer. Now when Q is on, the pump will be on. Now I will set this preset value as 20. So I have put this preset value as 20. So accumulator is moving towards 20, right? And you can see this Q value is off. It will become on when Q is 20. Now Q is on and pump is on. So this is where we can use the timers. So similarly, there are off delay timers. In the off delay timers, it is a little bit opposite to the on delay timer, in the sense that off delay timer turns off after some time, after some delay. On delay timer is the output Q turns on after a delay. So this is the way we can do different type of exercises in PLC fiddle, and we can use ladder programming to control different output actuators like pump, motor, or a solenoid valve, using by manipulating the sensors. The sensors can be of different type: proximity sensor, it can be some other type of obstacle sensor. And in the programming we can use math operators, compare operator, timers, and we can make a program that suits our application. So now I would like to close. Thank you, everyone.